And hello all, Mr. Callen here to help you on March 24th with our lesson 7.07b, Interpreting Review. You should have grabbed the Interpret a Quadratic Relationship in Context worksheet, and we're going to go ahead and start. Remember, please, we've been asking for quite some time, what are the important features of a quadratic relationship? Now, we've seen features like that in a table, where we notice there's not a constant first difference, but there is a constant second difference. And if you figure out that constant second difference, you can find how much the change changes. And in finding that first difference, then 240 plus 16 goes up, but then we reach a crest, a maximum, if you will, and it goes back down. So with tables, there's a constant second difference. With a graph, you're going to see a number of things. We like to call them y-intercepts. Y-intercept is going to be where the graph hits the y-axis. And what is this going to mean? Well, in this particular stomp rocket, it's launched at 4 feet. There's, of course, the vertex. Vertex is going to be the maximum point, which in this particular case means after about 3.5 feet, the stomp rocket will reach a maximum height of 8 feet. And one other key feature that we're constantly looking for is any x-intercept or intercepts. In this case, we have a single x-intercept at 9, and what does that mean? Well, it hits the ground, or is 0 feet high, after it travels a horizontal distance of 9 feet. It lands, it hits the ground, whatever the case might be. Keep those key features in mind, ladies and gents. And also remember to include those number or numbers when describing the features. So for instance, when talking about the vertex, yes, it will reach the highest possible point, a maximum height of 8 feet above ground, but don't forget to mention the other number, that's after traveling 4 feet horizontally. Meanwhile, not every key feature is going to be a nice integer. Sometimes it's not an exact 9 or 10 feet. But nevertheless, the ball hits the ground, the ball lands, the ball impacts the ground approximately 9 7/10 feet after it is launched. Make sure to include the numbers in your explanations. Don't forget, concave up looks like a smile, concave down looks like a frown, and you'll hear me use words like maximum, line of symmetry, etc. Now, what I'm going to ask you to do, get out your Desmos graphing calculator. You're going to need that software. And then go ahead and type this one in. Go ahead and pause the video and come back when you're ready. All right, I've typed the video. This program's not working out terribly great. Notice, please, if you need to zoom in, zoom out, please go ahead and do so. I'm going to zoom back in a little bit. And then I'm going to emphasize the key points on the graph. So the software is kind of acting up. So I'm going to keep clicking. And so what we have here, we have the key features of this graph, and we're going to answer each question in particular. Now, of course, I'm always going to ask you to mark that text up. So for instance, number 1 says, after how many seconds will it impact or hit the ground? Question 2 says, what is the line of symmetry? Question 3, how high will that object go? And question 4, what does that 40 represent? So I'm looking about how many seconds until it'll hit the ground, and I start at the starting value, the y-intercept, and it goes up, and then it goes back down, and it hits the ground at 15 point blah, blah, blah. We did ask in the directions round to the nearest hundredth, therefore, best answer is about 15 and 22 hundredths of a second. Now, in terms of the line of symmetry, we're looking for the midpoint, which the vertex always hits it. But which of those two quantities is it going to be? Now, the good news is, even if you mistake it, notice that 715 is not even on the graph. Oh, no. Yeah. But if I go back and type in the other point of 7.5, now you'll notice that goes through. So the line of symmetry should be precisely 7 5/10. Now, how high will the object go? That must be the 715 feet, again looking at the vertex. And what does the 40 mean? The 40 is the launch area, the place the object was launched from. Clearly it started above ground at about 40 feet above ground. So go ahead and pause, make sure you have the same answers, and then you may head back into the next part of the problem. All right, so I'm going to go ahead and I'm going to change my screen to the next quadratic relationship. So at this point, I hope you've typed in y equals negative 4.9x squared plus 60x plus 20. Let's go ahead and mark some text and go from here. So basketball player, so we're talking about basketball, throws a ball into the air. Initial velocity 60. It looks like that is crossed off and it says meters per second. And here is the relationship. Now let's mark that text. From what height was the ball thrown? How many seconds did it reach its maximum? What is that maximum? And when hit the ground? All right, so we look at this in particular. Go ahead and if you want, answer the questions, pause your video, come on back, and let's check it. From what height was the ball thrown? Well, that must be the initial place, or 20 meters above ground. Wow, they must be on top of the gym. That's not the best of problems, but that's okay. How many seconds until it reached its maximum? So where is it going to hit its maximum? That's going to be the vertex. Which of those quantities is the number of seconds? Well, that would be the x value. How long was that ball in the air? Appears to be 6 and about 1,200 seconds. Now the maximum height is going to be the 203. Again, rounding to the nearest hundredths place, that's not 68, that'll be 67. And when will the ball hit the ground? What goes up must come down, bam, and the 12, and that's going to be closer to, let's see, 56, 57 is going to be it. Now, if you'd like, pause the video, make sure you got the same answers, then go ahead and type in this new g function and come on back when you're ready. Now my g function looks really small here, so I'm going to go ahead and zoom in. Remember, you can click anywhere in the box or on the arc, and these gray dots will appear. So then you can individually click each of the gray dots to have them show up. All right, if you want, pause the video, answer the questions, come on back when you're ready. So the first thing I'm going to do, what are we talking about? Rock is thrown from a cliff. Initial velocity, 45 feet per second. This is the function of the rock. We're looking for axis of symmetry. How tall was that cliff? Maximum height, and how much time when the rock will hit the ground. So let's go ahead and answer each of these at a time. If you haven't done so, you can try to answer them yourself. Come on back and check your answers. The axis of symmetry, I'm going to predict, is going to be a weakness of the class. Again, the axis of symmetry, we are looking for the individual value where x will split it in half perfectly. So if I look at that vertex, and I'm thinking, which is the x value? I'm going to go ahead and type in 1 and 41/100ths. And you can kind of see here how it intersects that. So axis of symmetry should read x equals, not y equals. Y equals be a horizontal line, x equals is a vertical line. Now I'm going to come back and I'm going to re-click on the other points, and then we'll answer each individual question. Next question says, how tall is the cliff? So where are we looking on the graph? We're not looking at the x-intercept, we'll be looking at the y-intercept, which appears to be 30 feet from where the rock was thrown, 30 feet above the water. What is the maximum height? Okay, vertex again, so we're looking now, not the time, but the height, 61 and 64/100ths feet. And last but not least, when will it hit the ground is going to be about 3 and 37/100ths seconds. Now, pause the video if you need, make sure you got this, but this is what I'm going to check. Don't ask your partners for help. I want you to type in and answer the following questions. Then you're going to turn, that's the front side's going to be finished. We'll do the back side tomorrow. Then go ahead and turn that into your guest teacher. This is going to be how I find out what the class is good with, what do we need help with. We got a quiz coming up in a couple days. Folks, that's all I got for you. Take care, do well, let's grow. See you.